In solving trigonometric equations, it will definitely require us to review the coordinates of points on the unit circle. So we know that we have 6 trigonometric equations or functions. We have the sine function, cosine, tangent, cotangent, secant, and cosecant. We know also that sine of any angle theta is simply y. Cosine is x. Tangent is the ratio of sine and cosine, so we have y over x. Cotangent is the ratio of cosine over sine, or x over y, which is also equal to 1 over tangent. Secant theta is 1 over cosine theta, which is also equal to 1 over x. Cosecant theta is equal to 1 over sine theta, where sine theta is y, so we have 1 over y. Now these 6 trigonometric functions must be understood well, and you must be able to understand also the signs. So where can we find negative or positive, or in what quadrant can this sine function be positive or negative? So let's have a review. We have quadrant 1 here, quadrant 2, and remember, when we talk about the quadrants, our movement is counterclockwise. Okay, on quadrant 1 we know already that the sine of x is positive and the sine of y is also positive. In quadrant 2 we have negative, that is x, positive y. Quadrant 3 we have both negative. So for quadrant 4 we have positive and negative. Okay, so here, as we observe, we know that for cosine theta, that is for x, and sine theta, that is for y. Therefore, on quadrant 1, we already know that all of these 6 functions, since there's no chance that we have negative value, because both x and y are positive. Okay, so no problem for quadrant 1. All are positive values. However, when we proceed to quadrant 2, x here is negative. Therefore, those functions that require x must also be negative. Okay, so we start from positive. Sine is positive, so the reciprocal of sine is cosecant, which is also positive because they do not require x. However, the 4 remaining functions must be negative, all of them. So we have negative for cosine, negative for secant, negative for tangent, and negative for cotangent. Okay, why is it that tangent is negative? Because it requires cosine. Because we know that tangent theta is the ratio of sine over cosine. We proceed to quadrant 3, and as we observe here, x and y are both negative. Therefore, if we get the quotient of negative and negative, then we must have positive. So we have the idea that cotangent and tangent are the only 2 functions with positive values. However, the 4 remaining functions must be negative. Sine is negative, cosecant is negative, cosine is negative, secant is also negative. So we move to quadrant 4. On quadrant 4, the value of y is negative. However, the value of x is positive. Okay, so in this case, those that require x only will be positive. So what are they? Cosine is positive. Its reciprocal secant is also positive. However, the remaining functions will now be negative. So the one that requires y is sine function, so that must be negative. its reciprocal will definitely be negative, and that is cosecant. So the reciprocal, or the ratio of positive and negative, simply the quotient of positive and negative is negative. So we have negative for tangent and negative for cotangent. Now these different signs must be mastered by you, especially that when you move to solving trigonometric functions or equations, you are required to solve for negative or solving for positive. Then the basic step that you're going to do is to look for the quadrant, and then you go to the process now. So the next thing we need to review is the definition of reference angles. There are three commonly used reference angles. We have 30 degrees, 45 degrees, and 60 degrees. Expressing all of this in radians, so we have pi over 6 radians, pi over 4, and pi over 3. So what is the implication of the reference angles when we deal with solving trigonometric equations? So a while ago we talked about the signs, positive, negative, which is dependent on the quadrants. So the next thing we need to do here is the implication of the reference angles. Let's say, for example, you created an angle counterclockwise, and the measure of the angle, let's say, it's 30 degrees. Okay, so in the idea of unit circle, there exists a particular coordinates here. So we have x and y. So the next thing you need to understand also, sine 30 degrees is being represented by y, x is being represented by, that is cosine. So x represents or being represented by cosine 30 degrees. Going back to the definition, so if that is 30 degrees, opposite of it is 1/2. So this must be 60 degrees. Opposite, the length of the side opposite there, 60 degrees is square root of 3 over 2, and this is 1. Therefore, sine 30 degrees is basically x is square root of 3 over 2 and y is 1/2. So when we look into this square root of 3 over 2 is x and 1/2 is y. Therefore, sine 30 degrees is 1/2 and cosine 30 degrees is square root of 3 over 2. So what will happen if you will create another angle of the same reference angle? So we know that creating a reference angle is defined by the x-axis and the terminal side. So let's say this is 30 degrees. Therefore, the angle in green is 150 degrees. 30 degrees and 150 degrees are considered to be angles of the same reference angle. Therefore, in this case, if you have a point here on the unit circle, then we say that the x coordinate of this point on the unit circle is also square root of 3 over 2, and this is 1/2. However, since it is found on quadrant 2, then the x must be negative. So you can able to understand now the relationship. They may have the same, it seems like they have the same x and y. However, the coordinates or the sign of the coordinates will differ depending on the location. Okay, so let's have another angle. Let's say the angle counterclockwise. So this is again 30 degrees as the reference angle. Remember that the reference angle is being created by the x-axis and the terminal side. So the measurement of this angle in yellow, 180 degrees, half of 360 plus 30, so we have 210 degrees. So 210 degrees, 150 degrees, and 30 degrees are angles of the same reference angle. So it copies also. We have square root of 3 over 2 here, and this is also 1/2. However, since the next angle measuring 210 degrees is already found on quadrant 3, then these two coordinates must be negative. Okay, let's move to quadrant 4 of the same reference angle. Let's say, there you go. So you have 30 degrees here. So 360 minus 30 degrees will give us 330 degrees. This 330 degrees angle has also the same reference angle, which is 30 degrees. Okay, so since it is already found on quadrant 4, then the x coordinate must be positive and the y coordinate is negative. So the rule of reference angle is, upon observing the coordinates, they will just change. The sign will just change as you move from different quadrants. So basically, when you're asked in trigonometric equations, find the solutions. So if the question is finding the solution of a particular equation, let's say you are asked to find the same 1/2, positive 1/2, you observe there is positive 1/2, the other is also positive 1/2, then two possible solutions will be 30 degrees and 150 degrees. Also, when you are asked for the two values which are negative square root of 3 over 2 and negative square root of 3 over 2, then you are now referring to 150 degrees and 210 degrees. So that is the implication of reference angles as we move to solving equations. So the same thing will happen to 45 degrees and 60 degrees, but then we are just reviewing reference angles. Let us also review coterminal angles. So when we say coterminal angles, so if you have 30 degrees here and you have xy, and a while ago we already solved this, x is square root of 3 over 2 and y is 1/2, as we follow the rule of right triangle here. Now, when we talk about coterminal angles, if cosine 30 degrees is square root of 3 over 2 and sine 30 degrees is 1/2, coterminal angles would mean the same terminal angle. So if you move counterclockwise and you stop here, we'll also provide the same coordinates. They have the same coordinates. Also, if you move clockwise and you suddenly stop here, will also give us the same coordinates. So the angle that moves, the measure of the angle that moves clockwise is negative 330 degrees. However, the measure of the angle that move here in orange, the measure of the angle is 390 degrees. Now the idea of coterminal angles will also give us the rule of general equation. In the general equation, general solution, so the equation of the general solution would mean that we are already applying coterminal angles because we keep on repeating the value. We keep on rotating the angle, and we also keep on repeating the value, which will give us the idea of general solution, because infinite, the solution is infinite. It's possible. So when we are solving trigonometric equations, the first thing we need to know is identifying the different angle measurements in radian or in degrees that will satisfy the given equation. Now, because of the idea that when we talk about angles, then there is infinity in angles. Therefore, because we have infinite possible solutions, we are generating the general solution. When we say general solution, we are now creating an equation wherein it will give us infinite possible solutions. Now, to guide us in identifying the general solution, we are identifying first um, the solutions in interval 0 to pi or interval 0 to 2 pi. So we are referring here to the period of an angle. So we are specifying if the period is pi or the period is 2 pi, okay? And then we can now create the general solutions. So the general solution will definitely give us infinite rotations. So let's say if the solution is 30 degrees, then we keep on going back to 30 degrees. So we are creating an equation suggesting the general solution. Let's have examples. So let us start by solving cosine theta is equal to 1/2. So in here, we are solving for the theta that will give us a value that is 1/2 for cosine. So in here, it is obvious that we are using the inverse function. So the first thing we need to do is to rewrite that theta is equal to inverse cosine of 1/2. Observing that the value inside our cosine is positive, that sign will guide us as to where can we find the angle. Remember that the first thing we need to know here are the solutions in the period of cosine. We know that the period of cosine is 2 pi. And from that period, we are now referring to the interval of that period, and that is 0 to 2 pi. So we're referring to one complete revolution here. Cosine is positive when we talk about, when we refer to first quadrant, and so with the fourth quadrant. Therefore, we are expecting two possible solutions on the period of cosine function. Okay, so for us to solve or get the angle here, recall that if you have 30 degrees here, the opposite side measures 1/2. And this is 60 degrees, opposite of it is square root of 3 over 2. And this is 1. Therefore, cosine is for adjacent side. It is for adjacent side. Therefore, we are referring to 60 degrees. So constructing 60 degrees here, because we have now the idea that cosine 60 degrees is 1/2 by simply constructing this triangle. If this is the first angle which is found on quadrant 1, the next angle or the second angle must also have 60 degrees as the reference angle, and that is angle that measures 300 degrees. How did we get that? Because 300 degrees plus 60 degrees is 360 degrees. Okay, and as you check that in your calculator, cosine 300 degrees is equal to 1/2. But now, since we're referring to the solution, 60 degrees and 300 degrees must be converted into radians. So this is pi over 3. 300 degrees, multiply that to pi over 180 degrees. So recalling the conversion, we have, okay, we cancel 0 here. So 30 divided by 8. So 300 divided by 180 degrees will give us 5 pi over 3. Now these two are the solutions on the period 0 to 2 pi, on the interval of the period. We have two solutions, pi over 3 and 5 pi over 3. But as we go, or as we think, no, we know that there are infinite angles in trigonometry. So you might be thinking of the different solutions here. Therefore, the general solution will now exist. The general solution will now be provided because we have infinite possible solutions to that. Okay, so what will be the general solution? In the idea of coterminal angles, when you keep on rotating, no, So if you move here and go back to 60 degrees, okay, so you're forming 360 degrees plus 60, you have 420 degrees. The same will happen if you would like to rotate, no, using 300 degrees. So you keep on rotating 360 degrees. The general solution for cosine function is now being represented by theta is equal to pi over 3 plus, because you keep on rotating n number of revolutions, and that is 2n pi. The second will be theta is equal to 5 pi over 3 plus 2n pi. The condition here is n is integer. So it means to say, if you would like to have n that is equal to 1, then 2 pi, no? This n will become 1, so 2 times pi, 2 pi. So as if you're saying add 360 degrees to pi over 3. So that's what we say a while ago, that is 420 degrees. And 5 pi over 3 adding another rotation, one complete revolution, or it's up to you what is that n, would mean going back to the position of 5 pi over 3, which will definitely provide you the same answer, which is 1/2 and 1/2. Okay, that is the meaning of the general solutions. You can name all other solutions with the use of this equation provided. So the next problem is sine theta is equal to square root of 3 over 2. So we're solving for theta, and that is theta is equal to arc sine square root of 3 over 2. We are being guided also with a triangle here. 30 degrees, opposite is 1/2, and this is 60 degrees. Square root of 3 over 2. Since we're referring to sine and that is opposite, so we are now talking about 60 degrees, because opposite of 60 degrees is square root of 3 over 2. Now, sine here is positive. This is positive, square root of 3 over 2. And y is positive on quadrant 1. Actually, we have positive on quadrant 1. And y is also positive on quadrant 2, so we have negative, positive. We expect then that the two solutions on the period of sine function 2 pi are found on quadrants 1 and 2. So the first solution is that of 60 degrees. Okay, so the first solution is 60 degrees, or that is equal to pi over 3. Now the second solution can be solved by the idea of reference angle. So the same reference angle here is 60 degrees. So 180 degrees minus 60 degrees is equal to 120 degrees. The second solution is 120 degrees, which is equal to, okay, that is equal to 2 pi over 3. Now, we proceed to the general solution. The general solution will now be theta is equal to pi over 3 plus 2n pi. The other is pi over 3 plus, that is 2 pi over 3 plus 2n pi. So you see the importance of reference angles, coterminal angles, in the generation of the general solution of the problem. So let us have the third problem. Secant theta is equal to -2. So the first thing you need to do is to rewrite that. So theta is equal to inverse secant of, okay, so inverse secant of -2. And remember that if you have inverse secant of x, can also be equal to inverse cosine of 1 over x. So you are going to get the reciprocal of x, and that will be 1 over x. That will be very helpful in solving. Okay, so theta is also equal to inverse cosine of negative 1/2. Now the basis here is negative 1/2, and that is negative. That negative 1/2 is the value of x. Okay, so where can we find negative value of x? It is found on quadrant 2, the other is on quadrant 3. So we then expect two possible solutions under second. The first solution is on the period 2 pi. So in the interval 0 to 2 pi, we're looking for the values. You're now being guided using the triangle. Also on the triangle, we have 30 degrees, opposite 30 degrees is 1/2. Okay, and that is negative 1/2. So meaning to say you're using the adjacent because cosine is for adjacent side. So we have 60 degrees, cosine 60 degrees. However, cosine 60 degrees is positive. So we need to move to quadrant 2 having a reference angle of 60 degrees, and that is 120 degrees. So the first solution is 120 degrees. Okay, now the second solution is found on quadrant 3. So we again create another reference angle. So this will help you know, you might think of having an illustration when you're solving. So 180 degrees plus 60 degrees will give us 240 degrees. So we now have two solutions. One is 120 degrees, the other is 240 degrees. Convert these two in regions. 120 degrees is equal to, so you need to convert that so that you are being guided because we are using regions. So 120 degrees divided by 180 will give us 2 pi over 3 in radians. However, for 240 degrees in radians, and that is equal to 4 pi over 3. In the general solutions now, we are using these two angles found on the interval. Therefore, the general solution is theta is equal to 2 pi over 3 plus, since the period is 2 pi, so we have 2n pi. The other is theta is equal to 4 pi over 3 plus 2n pi. So why do we keep on talking about 2n here? Because you are rotating, you keep on rotating 360 degrees because you're trying to meet the same terminal. So you rotate and rotate as you go back to 240 degrees, or you want to rotate and meet 120 degrees. So that is the second. We actually have another way in solving reciprocals. So in here, we know that cosecant, we already know that cosecant theta is equal to 1 over sine theta, or sine theta is equal to 1 over cosecant theta. So we might choose to rewrite it into sine function. So sine theta is equal to 1 over 2 square root of 3 over 3, which is equal to 3 over 2 square root of 3. Rationalize. Okay, so we have 2 times 3. We can cancel out the radical sign. And 3 square root of 3. So cancel it out. So obviously, cosecant theta is also equal to sine theta, which is now equal to square root of 3 over 2, just because of the idea of reciprocal. And as you try to observe, 2 square root of 3 over 2 is just a reciprocal of square root of 3 over 2. Now in this case, we are now focusing on sine. We can make use of arc sine of square root of 3 over 2. Observing that square root of 3 over 2 is written positive. Now we go back to the xy plane. Positive, we have quadrant 1, positive y, and quadrant 4. sorry, quadrant 2. We have quadrant 2, which is negative and positive for y. Okay, I'm just making it clear. So we have negative and this is positive. Okay, so again, go back to the triangle. 30 degrees opposite is 1/2, so this is 60 degrees. Square root of 3 over 2. Now, sine function is for opposite, so 60 degrees. We have the first solution, which is 60 degrees. Okay, so on the period of cosecant, its period is also 2 pi. So we have the first solution under that period, which is 60 degrees, which is equal to pi over 3. The next solution is found on quadrant 2, okay, with a reference angle which is 60 degrees also, and that is 120 degrees. So we have 120 degrees, which is equal to 2 pi over 3, okay, in radians. Therefore, we now have the general solution. In the general solution, we will just get theta is equal to 60 degrees. Now we are using the radian. We will now use the radian of it, and that is pi over 3 plus 2n pi. The other is theta is equal to 2 pi over 3 plus 2n pi. So we use the rule of arc sine as well as the rule of its period, which is 2 pi. So that is true for sine, cosine, secant, and cosecant. The period is 2 pi, so we always have 2n pi. So the next problem is about tangent theta is equal to square root of 3. Okay, so the first thing we need to do again, theta is equal to inverse tangent of square root of 3. Now for square root of 3, and that is positive as observed. Now if we go to xy plane, it is quadrant 1 that can give us tangent that is positive, and also with quadrant 3, negative and negative. Now to get the theta, the measure of theta, we can use the triangle again as our clue. So this is 60 degrees. Since that is square root of 3, meaning to say tangent is the ratio of sine over cosine. So sine theta must be square root of 3 over 2, and cosine theta must be 1/2, so that we can have square root of 3, because square root of 3 over 2 divided by 1/2 is equal to square root of 3. And what measure can provide us that particular answer, that is square root of 3? It is 60 degrees, because we have cosine 60 degrees, which is equal to 1/2, and sine 60 degrees, which is equal to square root of 3 over 2. So when you divide square root of 3 over 2 by 1/2, it will give you square root of 3, and that is what we need. Therefore, on the period of tangent, we know that the period of tangent is just pi. Okay, now on quadrant 1, we have the first solution, which is 60 degrees. 60 degrees is also equal to pi over 3 in radians. Now the next solution is found on quadrant 3. The same reference angle, and that is 60 degrees, so 180 plus 60 is 240 degrees. This 240 degrees in radian is also equal to 4 pi over 3. Now, if you try to observe the rule of tangent and cotangent, it is always opposite. It is always opposite. So we have quadrant 1, then its partner is quadrant 3. Why? Because they both give positive. The partners naman sa kabila, we have quadrant 2, it gives negative, quadrant 4, which is negative. Because for tangent, it is there's a need for you to understand x and y because it will provide you the final sign. Therefore, in the general solution, we can just use 60 degrees and that is already enough. Let's prove it. Theta is equal to pi over 3 plus, because the period of tangent is only pi, then we have n pi. So it's like adding, no? It's like always adding multiples of 180 degrees. Why? Because as I've said here, if you move here, then you always have half of it, 180 degrees, then you move again another 180 degrees. You are not forming here 360 degrees because you need to move 180 degrees at a time, okay, for you to get another solution. Now, to prove that theta can just be equal to pi over 3 plus 2 pi, let's say n is equal to 1. So you have pi over 3 plus pi. So we have, you see, we can have 4 pi over 3 here. We can immediately have 4 pi over 3, meaning to say we can just express the general solution into theta plus is equal to pi over 3 plus n pi, because you can generate na 4 pi over 3 out of it. Okay, so 1 is enough, and that is on the period. So when you are asked to just get period 0 to pi, your answer can only be 60 degrees or pi over 3. However, if you are asked to provide the answers from 0 to 2 pi, then these two must be your answers, pi over 3 and 4 pi over 3. So for the next problem, cotangent theta is equal to -1. Okay, so you need to write it again. Theta is equal to arc cotangent -1. That -1, okay, as stated, that is negative. Therefore, on the xy plane, it is quadrant 2 and quadrant 4 that can provide us negative value for cotangent. Actually, because the reason here is in quadrant 2 we have negative, positive, and in quadrant 4 we have positive and negative. These two will provide negative and negative for cotangent. Now, remember that sine 45 degrees is square root of 3 over 2, square root of 2 over 3. And cosine 45 degrees is equal to square root of 2 over 2. And when you divide these two, will give you 1. Therefore, you have the idea that theta is 45 degrees. However, that is negative. Therefore, you need to recognize now the location of this angle. So on the solution under the period of cotangent is pi. So when you are asked to provide the period or provide the solution from the period 0 to pi, there must be only one solution. And what is that? It is this. The reference angle is 45 degrees. So this is the terminal side. So you move here, 180 degrees minus 45 degrees, that is 135 degrees. That is the only solution from the interval 0 to pi. But when you are asked to provide the solution from the interval 0 to 2 pi, then there is another. It is found on quadrant 4. Recognize the 45 degrees as the reference angle. So you move here, and the answer is 315 degrees. So we have 315 degrees, another solution that can be found when we proceed to 0 to 2 pi. So when we talk about 0 to pi, we have 135 degrees, and 0 to 2 pi, actually, dalawa sila. 135 degrees and 315 degrees. Now, 135 degrees, express that into radian. So over 4 yan, and that is equal to 3 pi over 4. For 315 degrees, when you express that in radian, that is 7 pi over 4. But since cotangent has a period that is pi, we will just recognize 135 degrees. Okay, because it will also repeat what 315 degrees in the general solution. So when we talk about the general solution of cotangent here, we can now have theta is equal to 3 pi over 4 plus n pi. Remember that this n pi or n is any integer. Okay, that is always set of any integer. Now let us prove that you can have 315 degrees out of this general equation. So when n is equal to 1, so we have theta is equal to 3 pi over 4 plus 1 times pi. So 4 times pi, okay, 4 times pi is 4 pi plus 3 pi is 7 pi over 4. You see, we can actually generate 7 pi over 4 out of this general solution. That proves that we can actually make use of the single general solution now because of the period pi. Okay, so let us generalize. So how do we identify the general solution of the 6 trigonometric functions? So when we talk about sine, cosine, secant, cosecant, okay, of any angle theta, remember that their period is 2 pi, okay, period is 2 pi. Therefore, when it comes to general solution, then you need to recognize, okay, 2 and pi. Always recognize 2 and pi. However, when we talk about the next two functions, cotangent theta and tangent theta, the period of these functions is pi. So when it comes to general solution, that is plus 2 and pi, here you are going to add n pi. So what we're going to add, that is n pi, but you need to first solve for the solution. So what are you going to place here? It is the first solution. Okay, so in the general solution under the first four functions here, that is 2 pi, so you're looking for two solutions under the interval 0 to pi. So you have two solutions in this period. Okay, therefore you're expecting two general solutions. So we have two general solutions in this case. However, in cotangent and tangent, you can only have one general solution. And in the idea of period, so the first thing you need to identify here is the smallest angle that can provide the solution. So get that angle and add that to n pi to get the general solution.